Hi guys, so here I've got a question from the AQA exam board. It's actually a differential equations question, but it's a very interesting one. Let's just have a look at it. So a zoologist models a disease which is spreading through a colony of rabbits. The zoologist assumes that the rate of increase of the number of rabbits infected is proportional to the product of the number of rabbits infected and the number not yet infected. First of all, it's talking about something quite complicated. Product of the number of rabbits infected and the number not infected, and it's proportional to the rate of increase of the number of rabbits. So already it's starting to phrase it quite complicated, and I do suggest that you have a go at this question and then watch this video to find out sort of how to do it, because you will get stuck undoubtedly at a certain point. Alright. At time t days, x is the number of rabbits infected. The zoologist estimates that there are 5,000 rabbits in the colony. So we can basically say 5,000 is our total. Initially, the number of infected rabbits is 200. Initially, the disease is spreading at a rate of 50 rabbits per day. Whenever a question says initially, you know we're dealing with time equals 0. Alright. Use the zoologist's assumptions to answer the following questions. Show that this is going to be our differential equation. Now, it does seem very easy to get this. For one, first of all, what do we do? Well, we say dx dt. So this is our rate. We were told it's proportional, so k, to the product of the number of rabbits. Well, we don't know what the number of rabbits is. We've got a variable here, x. Number of rabbits infected and the number not yet infected. Now, if there are x infected and the total population is 5,000, we surely know that, well, the ones that aren't infected is just going to be the total population minus the ones that are infected. So we get this. Now clearly what we can do, we can divide by this, x, and divide by 5,000 minus x. So we get this. 1 divided by 5,000 minus x times by x. dx dt, really important to remember to put this in. And this is equal to k. Now, this is probably where, if you had a go, you would be confused. This and this is very different. You're probably thinking, well, surely maybe we're going to have to put a plus. But it did say product, and product means times. And this is where you've got to be careful. And where I sort of advise people to sort of work backwards. So let's take this left-hand side. We're going to get 1 over x plus 1 over 5,000 minus x. I'm just ignoring this dx dt. I just want to rewrite this, and maybe I'll be able to get it in a similar form to that. Well, for one, let's combine the fractions. So on the left side, we're going to get 5,000 minus x plus, and it's going to be plus x. And of course, they have to have the same denominator like this. Now, if it isn't already, you may start to see a bit of similarities. The denominator that we found is very similar to the denominator that we've got here, and all we've done is combine the fractions. What can we do now? Well, we can simplify the top. The x will cancel. And we get this. So we get 1 over x times 5,000 minus x is equal to this. In this case, we have 5,000 of them. Yeah. So what we can do is, using what we just found, is we can actually now times both sides of our differential equation by 5,000. And what that's going to do it's going to allow us to split the fraction up like this. So we can times it by 5,000. dx dt, and of course when you're timesing one side by 5,000, make sure to times the other side. Now for the 5,000k, obviously we're looking for a q, so we can say q is equal to 5,000k. So q. For our fraction, we've already shown it can be rearranged in the way we just did, so we can actually just say, well, this is the same as 5,000 minus x plus, and then it's going to be x over this dx dt, and of course now we can now split them up. To give us exactly what we were after in the question. Now, not always is it going to seem totally obvious what to do, and that's why I sort of encourage you to split or work with this, combine the fractions, try go like a step backwards in order to make doing this, what we've just done here, a lot easier. You could have noticed from here, well yeah, we're going to have to split them up using partial fractions. You could have done that. This method is also valid, and I feel it's a simpler method just by having a look at what we're after. We're after a plus. Yeah, we could have done partial fractions. Or we can combine them, look for similarities. We did that, and we got our answer. Thanks for watching.